Hi everyone, welcome to chapter 2 of Intro to Stats. We are going to talk about descriptive statistics today. It involves organizing and summarizing data. To do this, we can use various types of tables, graphs, and numerical descriptors. So we're going to start first of all by organizing data through this thing called stem plots. And another way we say it is stem and leaf graphs. So we have this set of data, 9, 9, 22, 32, etc. So the way a stem and leaf plot works is the first digit in each of those numbers is the stem, and the second digit in each of those numbers is the leaf. All right, so 9, the stem is 0 because it's like 0, 9, right? So the stem and the leaves, we have this 0 with two nines means there's a 9 and a 9. There's nothing with the first digit of 1. Then there's a 22, there's a 32, a 33, a 39, a 39, etc. Okay? Sometimes the smallest and or largest values are what we call outliers. So they're atypical data values in that set of data. And they're sometimes referred to as extreme values. And we're going to talk about how to recognize whether a data value is an outlier or not. All right, so the following data show the distances in miles from the homes of off-campus statistics students to the college. Create a stem plot using the data and identify any outliers. So there we go, 0.5 as a stem of 0 and a leaf of 5. So we set up the stem and leaf plot like that. And then the only one that looks like it could be an outlier is 8.0. We go from 5.8 to 8.0. That's a pretty big leap. 8.0 is pretty far away from that cluster of data, so it could be an outlier. Line graphs. So a line graph, the x-axis consists of data values, the y-axis consists of frequencies. So here we're going to do an example. In a survey, 40 mothers were asked how many times per week a teenager must be reminded to do his or her chores. So number of times a teenager reminded 0 times, frequencies 2. One time, 5 different mothers said they had to remind their kids 1 time, and etc. So then I graph those points, right, 0, 2. So number of times a teen is reminded 0. The frequency is 2, so I plot 0, 2. Then I connect the dots with lines. Hence, we call it a line graph. Bar graphs consist of bars separated from one another. So the population of Park City is made up of children, working age adults, and retirees. The table shows percentages of populations of each group. And create a bar graph. So children, we have 19%, adults 43%, retirees 38%. I just draw bars up and there it is. Histograms are a little different. They represent frequencies of grouped data. Okay, so they differ from bar graphs in that their rectangular bars are touching. A bar graph, right, the bars don't touch. They're totally separate. A histogram, they're going to be touching. So the following data are the shoe sizes of 50 male students. Construct a histogram. So we're going to choose 6 bars. So the first bar is going to have all people that have shoe sizes between 8.5 and 9.5, including 8.5, but not 9.5. All right, so therefore, when we do the frequencies here, you're going to see that between 8.5 and 9.5, with 8.5 being included, indicated by the less than or equals to, and the 9.5 not, there's only 2 values that represents, and those 2 values are the 2 nines. Alrighty, these 2 values are the 2 nines. All right, so, and then from 9.5 to 10.5, well, there's 1, 2, 3, 4, 5, 6, 7, 8 of them. That's why I got a frequency of 8. Then it looks like we have 50 students, so then the relative frequency is the percentage. So 4% of the students have shoe size between 8.5 and 9.5. 16% between 9.5 and 10.5. So then I draw this table out, and then by doing the table, it's easier to do the histogram. All right, and then here's the histogram down here. The shoe size is going to be on the x-axis, so that gives you the groupings from 8.5 to 9.5. You look at the bar, it's 2 high, and then from 9.5 to 10.5 is 8 high, right? So then I just draw bars to represent those frequencies. All righty. Okay, moving right along, we are cranking through this. Measures of the locations of data. So quartiles separate the data into quarters. The first quartile, 25% of the data values are less than or equal to Q1. All right, so if you look at the shoe sizes here and you look at the frequencies, you got 20% of the people are going to be less than a size 10.5. So 25% of the people are going to have less than 11.5, right? Because you add the 42% more. So somewhere in there is going to be the first quartile. All right, so the first quartile is going to be between 10.5 and 11.5. And we're going to be able to use a calculator to do those, and I'm going to show you how. All right, the second quartile is called the median. So half the data is above the median, half of the data is below the median. The third quartile, 75% of the data are less than that number, and 25% are greater. So if we look at this example, you're going to have a couple like this on your assignment, your MyOpenMath assignment. You have this example with these data values. We got 14 data values in the list. The first half of the data value has 7 data values, as does the second half. So I put that squiggly line there to indicate that. Alrighty. Then when we do the median, because it has an even number of values, when you find the median, you're going to have to take the average of those middle two values. That's how we came up with a median of 7. Q1 is the middle value of the lower half. Well, the lower half has 7 values. The middle number is what I highlighted in green right there. So the first quartile is 2. And the third quartile is 9, because that is the midpoint or middle of that second half of the data. Interquartile range, IQR, you just take Q3 minus Q1, and that gives you the range between those two quartiles. So the interquartile range is 7. All right. Outliers. Let's talk more about outliers and how to figure out what would be an outlier in a set of data. So an outlier is a data value that is significantly different from the other data points. So a value is a potential outlier if it is less than Q1 minus 1.5 times the IQR, or greater than Q3 plus 1.5 times the IQR. So I did that for this example. The lower value for an outlier that went downward to the low side would have to have negative 8.5 as a value. So there's no outliers in that set of data up there, this set of data here, no outliers down below. Up above, the upper outlier is going to be 9 plus 1.5 times the IQR again, so 19.5. There's no values in that data set bigger than 19.5 either. So there's no outliers either upward or downward in that one. Percentiles. Percentiles divide the data into hundreds. If you have taken the SAT test before, you're going to be given a percentile of your score. You're going to be told your percentile is 80%. Hey, that means you did better than 80% of the people that took the test. All right, so the kth percentile is the number for which k% of the data is less than or equal to that number. To find the kth percentile, the data has to be arranged from smallest to largest. Then I calculate I, which is k over 100, times n plus 1. This gives the position of the kth percentile. And then if I is an integer, then the kth percentile is in the ith position in the list. If I is not an integer, then the kth percentile is the average of the two data values in the positions corresponding to the nearest integers above and below I. All right, so 50 people were asked how many hours they spend each day on average watching TV. So 10 people said they watch 2 hours a day, 12 people watch 3 hours per day, etc. What is the 44th percentile? So we first make that I calculation. So 44 is what K is, so I put 44 over 100, and then N is 50, so I have 50 plus 1, then I have 22.44 is my I value. So that means the 44th percentile is going to be the average of the 22nd and 23rd data values. So it looks like there's 10 2s and 12 3s. So the 22nd data value, right? Remember, these frequency distributions mean that you would, if you wrote out this set of data here, you'd have 10 2s. Then you'd have 12 3s. So I'd have 2, 2, 2, 2, 2, 2, 2, 10 times. 3, 3, 3, 3, 3, 3, 3, 12 times. So the 22nd data value is a 3. The 23rd data value goes to a 4, right? Because the 23rd, it looks like in the next 14 values are going to be 4s. So we take the average of 3 and 4, and we find the 44th percentile is going to be 3.5. That means 44% of the data values are below 33.5, and 56% of the data values are above 3.5. All right, well, what if you're given a data value and asked what percentile it is? So first thing we're going to do is we're going to order the data from the smallest to the largest. Then we're going to calculate K. K is going to be X plus 0.5 times Y over N times 100. That's a complicated calculation. All right, and we're going to round K to the nearest integer. So X is the number of data values less than the data value for which you're trying to find the percentile. Y is the number of data values equal to the data value for which you want to find the percentile. N is the total number of data values. Okay, and we're going to use that formula. All right, so let's do an example. Find the percentile for 8.3 here. So I have X equals 9, so there's 9 values, 1, 2, 3, 4, 5, 6, 7, 8, 9, that are less than 8.3. All right, I don't know if you guys can see my arrow here, if y'all can see my arrow, but 1, 2, 3, 4, 5, 6, 7, 8, 9 values less than 8.3, so X is 9. Y is 1 because there's only one 8.3, and the total number of data values is 14. All right, and then I make that calculation. I could put that on my calculator, and I come up with 67.86. And then you're rounding. It tells you to round to the nearest integer. Round K to the nearest integer. So the nearest integer to 67.86 is 68. So 8.3 is the 68th percentile. All right. Another way to represent data is with a box and whisker plot. This actually tells us a lot. You basically plot dots for the min value, the max value, Q1, Q3, and the median. So I would put those on there first, right? Put a dot on the min, put a dot where Q1 is, put a dashed line where the median is, a dot where Q3 is, and a dot where the max is. All right, so this is probably the same set of data that we looked at before, with the Q1 being 2, the Q3 being 9, and the median we calculated to be what? Let's see, there's 14 sets of data, halfway between 6.8 and 7.2, so 7. And it gives you a nice visual because you see Q1 and Q3 are 7 apart, so the IQR is 7. So box and whisker plots are pretty powerful representations of your data. All right, measures of the center of the data. All right, the mean is simply the average of the data. So X bar is the sample mean. Mu is the population mean. We learned about that in chapter 1. The median splits the data into 2 equal parts. So it's basically Half of the data is below it, half of the data is above it. And the mode is the data that happens the most. All right, so the following data show the number of months people wait for a transplant. Find the mean, median, and mode. All right, so we're going to learn how to use the graphing calculator for these calculations. All right, I am going to show you a video on how to use the calculator. If you do not have a calculator, tihub.org is going to show you a nice calculator. All right, now let me try to split it so I can look at the data and my calculator at the same time. Here we go. All right, hopefully you could still see that. And I am going to put that data into a list. So here are the steps that we're going to use. We go stat. Right there, you hit the stat button and then enter on edit. Then you're going to see this chart and you have all these lists here. And I'm going to just enter that data into the list. All right, so I'm going to enter 3, 4, 5. There's 4 7s. There's 2 8s. 2 9s. There's 1, 2, 3, 4, 5 10s. There's 1 11. 2 12s, 1 13, 2 14s, 2 15s, 2 17s, 1 18, 3 19s, 2 21s, 2 22s, a 23, and 4 24s. And it looks like there's 38 values. Now, if we don't get the same answers that I get right here, we messed up on the list somewhere, okay? So now to find the median and the mean, and it's going to give you the quartiles and everything. And it's also going to give you what's called the standard deviation. All right, we're going to talk about that here in a couple minutes. So now I'm going to go back into stat. And I'm going to go over to calc, and I want to do 1 var stats on that. So when I hit enter, you're going to be asked for the list. I want to find the 1 var stats on L1. If you entered it as a frequency distribution, right, like we could have said, okay, the data value is 3, and then in L2 I could have entered a 1 because 3 only happened once. 7, I would have put 7, and then over in L2, I would have put 4 because it happened 4 times. So if you enter the data like that, you would need to put a freq list in. We did not, though. We just entered them each one at a time. So list L1, freq list I'm going to leave empty, and then calculate, I hit enter on, and there are your 1 var stats. So obviously, we did something wrong here, because it does not look like I got 13.9 as my X bar. So I could go back to stat. Maybe I did it wrong when I did the notes the first time. So stat, edit, we could check. Yeah, see, I forgot a 5, right? You see that 5 right there? I did not put that 5. So now I'm going to go down to the bottom. This is good that I made a mistake here. It shows you that, have some perseverance. Work through it. And then I got to put a 5 in. Let's see. There we go. 5. Enter. Okay, let's try it again. So quit out of here. And then I'm going to go stat, calc again. 1 var stats. There we go. 13.9. All right. So troubleshooting. Very important. So X bar is going to be the mean, so 13.9. S sub X is going to end up being the standard deviation if this came from a sample. It would be 6.36. That little circle thingy right there is called sigma. If that data is the population, that's going to give the standard deviation of the population. All right, so there, our min value is 3, quartile 1 is 9, median's 13, our quartile 3 is 19, and our max is 24. That would give you the 5 values for your box and whisker plot, also called a 5-number summary. Alrighty. Alright, moving on. If the data are given to you as a frequency chart, here's how to calculate the mean, median, and mode. Perfect. So we are going to do the same thing, and we're going to go stat, edit. Now this is good because L1 now has data in it that I don't want. So I need to clear that out. So the way to do that, you go and highlight L1, you hit clear, enter, and it clears it, okay? Now I'm going to put that data in 2, 3, 4, 5, 6. Go over to L2, 10, 12, 14, 8, and 6. And then, hopefully we did it right this time. We don't have to go back. I'm going to go to Stat, Calc, 1var Stats. This time, I'm going to go Freq List L2. Well, you'll see the numbers in blue down here. L2 is above 2. So I go second, 2. Now I have L2 in there. Then I can calculate. And lo and behold, there's my mean, 3.76. My median, 4. Mode, you're just going to have to look at the frequency. What happens the most? The mode was 4 because it happened 14 times. I failed to mention the mode in the last example. Last example, the mode was 10 because 10 happened 5 times. It happened more than any other data value. All right, that's the first part of the Chapter 2 notes. We're going to have to separate it into 2 videos because my video program only accepts 25-minute videos. All right, so look for the second half of Chapter 2 in the next video.